Hello and welcome to Microfile, a chance to see again some of the items from the recent series of Micro Live.
Well, although computers are being used in an ever-widening range of areas, how they can apply to what you do or benefit your business may not always seem so obvious. Well, this week's programme goes back to basics, starting with an introduction to word processing.
Oh. The problem with a typewriter is, well, when you're trying to edit the text after it's been committed to paper. Now, of course, ideally, the paper copy would be the final stage. And that, of course, is what the word processor is all about. You can make all your changes before you commit yourself.
Well, this is a BBC Micro running a package called WordWise. We've used the B because it lets us show the screen more clearly, but there are word processing packages with similar features for just about every Micro on the market. Well, the first thing to note with any word processor is there are two ways of working. One to enter and edit the text, the straightforward typing, what I'm doing at the moment, and the other is for commands or instructions to tell the software what to do with the finished product. And we have a list of them here. We could save the text, we could print it out, etc., etc. As far as the computer's concerned, it's as if you're in two separate rooms. With this package, it's easy to see which room or mode you're in. You can switch or toggle between the two. The screen layout is quite different, and the various possibilities are selected from this menu here. But with some word processors, you have to type those commands in. Right, well, let's see how the word processor helps you write. I'll move into the writing mode, and that's one key depression on almost every system that you find. And as you can see, I'm working on a bit of a spoof letter here. I'll add a few more words in. I've been looking for a new job for 5 years and cannot find... Now, one of the things you find here, if I was typing here on an ordinary typewriter, the bell would ring to indicate the end of the line. I'd have to hit a character turn to go on to the next line. But the software does take care of this. Cannot find one, and it doesn't split the word, it puts the word completely on the next line. Now that's called word wrap, and it's a feature of all word processors. It means you can just go on typing without looking at the screen. But the word processor really comes into its own when you want to correct your mistakes. And the key that does this is the cursor, this little flashing bar here, the cursor. And it can be moved around using the arrow keys. So I have made a mistake up here. I just move the cursor over onto it, put it underneath it, and I want to replace that. So I go into overtype mode, I replace the F with an R, and it's simple as that. You'd never know that the F had ever been there. But word processors can do far more than just correct typing errors. You can make much more fundamental changes. Suppose I wanted to actually insert a word in here. I'll go down to this line here and position it. Now I'm going to go into insert mode. There's always two modes here, one to overtype what you've written and one to insert some new text. So I wish to apply for a job as a journalist. And as I'm typing this, automatically the words are being wrapped around and put on the next line down. Well, what about a major change? Perhaps I'd like to move the bottom paragraph in between the two first paragraphs, and that's fairly straightforward. I take the cursor down again, I put a marker in there, I put a marker at the end of the passage or text that I want to move, and then position the cursor again right on the line where I want it to be, and then move the text. And there I've got my letter fairly well structured. I could just as easily delete a paragraph or insert it twice or whatever. Now, if that was all the word processor did, it would still be worth having. But there's much, much more. For example, suppose you wanted to change a word every time it appeared. Now, in the last paragraph, there's two no's in there. Now, I might want to change that. So I go into the command mode, and I've got a search and replace here. Now, this says global or selective, G or S. Global means I replace every time the phrase appears, and selective means it will give me a choice to check each time. Well, I'm going to check, so I'll put an S. Please enter the search string. Well, I want to search for the times when no appears. That's no, and I type that one in there. And it's going to ask me what I'd like to replace it by. And I think I'd like to replace the no by am cog no sent with. That's a nice phrase to put in my letter. And am cognoscent with will replace no. Now, if I hit the key, it asks me here, do I want to replace the no here? And I am cognoscent with the difference between buffered and non-proceeding. Sounds really quite pompous and should improve the letter no end. So I'll say yes to that. And down here, it's asking me, do I want to replace that? No. Well, who work for you I'm cognizant with doesn't make any sense, so I'll say no to that one. And there is my letter. It's looking quite reasonable. Of course, this is really only useful, this replacement, when you have a long letter with lots and lots of changes. And depending on the software you're using, well, there's plenty of other things I could actually do with this letter. But what you can't do is switch off the computer and come back tomorrow and expect that the letter will still be there. At the moment, the letter only exists in the computer's memory, right in there. So it must be put somewhere safe whilst the computer is switched off. In this case, we're going to put it onto disk. So I go back into the command mode. One, to save the text, it asks me to enter a file name. I'll call the file Mac. And the light comes on, and I can just hear it writing onto the disk, and that's saving the letter. Well, computers do go wrong, or you can even make a mistake yourself, so it's worth saving your work every 10 minutes or so. So this letter is ready to print. To make it easier to read, the software gives us 40 characters or 40 letters to the line, but it prints out at 80, and we can see what it looks like by pressing one key. And there it is. Now we can see exactly what the letter really looks like. Of course, we could alter the width to anything we want before printing it out.
Well, you can get used to the quirks of almost any word processing software, but what the finished letter looks like on paper depends on the sort of printer you buy. Basically, there are two sorts, daisy and dot. A daisy wheel contains a wheel like this, which has all the letters and the numbers on it. So it can give you perfect type. They're very reliable, these machines, and they're getting cheaper. This particular one, this Juki, costs about £250. But one problem can be this, the noise. It clatters quite unbearably. Well, I get shot of that, I think. That's all I can stand. And the other thing is they aren't really designed for pictures or graphs. So if you want a more versatile printer, then you'll need a dot matrix. Now, this type uses a series of dots to make up the letters. As you can see, the problem with this sort is the slightly speckled effect. There are dot matrix printers that get round this by double striking. They're called NLQ, or near letter quality, and they can look quite good. This particular one is a brother, and it costs only about £110. And here is the variety of things you can get from it. There are different widths, different boldnesses and so on, even italics. So, a resume of what you'll need to start word processing. If you've already got a computer, then you'll need a reasonably clear monitor. Well, a black and white one will cost upwards of about £80. You'll also need a disk system. This is quite an expensive setup here, but they start at about £100. You can just about get by with cassette, but it's terribly, terribly slow. Then you'll need a printer and, of course, the software itself. That's anything from about £5 to £100. Yes, it all adds up, but it's not to the prohibitive amount that it used to. And if you're starting with nothing, you could get a complete word processing system for as little as £400.
Word processing has been available for a while now, but technology fairly gallops along.
Mention publishing, and for most people, this is the image that comes to mind. Until recently, this is the kind of machinery you'd need to get a decently printed page. The page is created by photographing what you want to print and etching it onto a metal sheet. In fact, rather like this one, which is then wrapped around the cylinder in here. And I'll just spin this around, and we'll see the cylinder. There it comes, and indeed, that is the metal sheet. Now, the cylinder itself is inked by these rollers, and the image is transferred via this rubber-covered drum down onto the paper. Now, believe it or not, this is the easiest part of publishing. The real time waster is creating the original piece of paper to be photographed. By the time you've worked out what you want and where to put it, then you've made a few changes, given it to the printers, checked it, rechecked it, probably changed your mind, you might have lost 3 months. But there was no alternative if you wanted to get something better than typewritten. And then about 3 years ago, Apple's laser printer changed all that. Take a look at the quality of this compared with the sort of thing you used to be able to get with the typewriters or impact printers. So, when Apple connected the laser printer to their notoriously friendly Macintosh, they had the beginnings of something really big, desktop publishing. Now, desktop publishing is a combination of the hardware and the software, in this case, PageMaker. which lets you produce professional quality print at a fraction of the cost and time involved in the traditional methods. You've always been able to draw and write, of course, on the Mac, but the PageMaker software allows you to take the articles and the diagrams and arrange them as you wish in a page format. For example, here is a representation of what we've got on the page, but I've decided I want to put in this extra bit of text here. Well, couldn't be easier. I simply, I'll move this out of the way to make room for it. I do that simply by clicking on with the mouse. Now I'll move this text down to the bottom. That's very straightforward. Put that there. And I'll put in my extra text. Now, of course, that doesn't leave room for the graph, not as it stands, but I can move it around a bit. Let's pop the graph up there. Of course, it's the wrong shape at the moment, but it's no problem just to click onto the mouse and alter the format of that graph to fit the hole. And there it is, totally new format. So I've changed the format, but equally I could change the font, the type size and so on. And I print out only when I'm totally happy.
The Macintosh started a whole new ball rolling, and it didn't take other manufacturers long to follow. And what was a relatively simple idea turned into the 1987 money spinner. Mac talked to Graham Hallett, an expert on desktop publishing.
Well, the Mac's been around with that sort of software for some time now. Yes. Let's have a look at what's available on the IBM systems or their compatibles.
Right. Oldest PageMaker, the program we just saw, of course, is now available on IBM-type systems. But this is a fairly professional configuration that we have right here. The compact Despro 386, a very fast processor, a professional-sized screen. And in fact, this is a different package called the Xerox Ventura Publisher, which is more oriented towards longer document production, such as a book. This is a 250-page book, in which the style is going to be fairly constant throughout the publication.
And any changes you want, you must run from page to page right throughout any chapter.
Yes, and it works very, very effectively, as you'll see. This is a document of about 15 pages, as you'll see. If we flick to the next page, we have the odd bit of graphic in it. If I click to the end of the document, see how quickly we process through the 15 pages. But let's go back to the beginning and make a few modifications. What I'm going to do is I'm going to put a frame in here for a diagram. There we go. Let's actually put a graphic in it now. That diagram there.
That's a lens of a camera you put in there.
I think so, yes. Now, just to see what effect that's had at the end of the document, let's flick to the end, because inserting that diagram, of course, means that the end of the document has gone, still is balanced, but is right now down at the bottom of the page.
That's great.
An Apple Macintosh setup with a laser writer will cost around £8,000, and a comparable IBM system upwards of about £10,000. The laser printer alone will cost between £3,000 and £5,000, and there's an additional cost of something like 3p per page, about the same as a photocopier. So a laser printing system is a heavy initial outlay, but it does become more cost-effective if it's shared by a network of users. In fact, desktop publishing lends itself beautifully to group use. Writers, designers, artists and so on can each make their own contribution.
Investing in a computer system for your business is not an easy step to take. With the enormous range of systems available, or with strengths and weaknesses in different areas, making that final choice can be a nightmare. So it was with some trepidation that John Wilson chose to buy quite a large system for his jewellery business in Dundee.
I had no previous computer experience whatsoever. The limit of my experience was with a small Spectrum computer, which I didn't understand and couldn't really use. We've purchased this very large computer system. It's probably a system that's much bigger than you would anticipate to see in originally a single shop. We had so many stock lines and wanted to do so much that the system had to be initially very large and very expandable.
The computer looks after all the stock records for the shop, and that alone is useful, but its real value lies in the sales reports that it produces. These identify the performance of every one of the designs in stock.
Without the computer, it would never have been possible for us to really establish what was selling and what was not selling. I don't think it's humanly possible to look after 6,500 lines. Even 1,000 lines becomes totally impractical. We previously were essentially having the wrong information fed back to us. The information we were getting was subjective. If I was in the shop and happened to sell 2 of something, I then thought that that was a line that the customers were buying. That turned out to be, in most instances, completely erroneous. We now have objective information. We have the correct answers to our buying decisions and our stocking decisions. A combination of all these factors had also allowed us to display the goods that the customers want to buy. The traditional conservative jeweller would stock from silver plate through to quality jewellery, expensive diamond rings, and all the other things that are associated with the jewellers. Some of these things are not profitable to stock, both in terms of physical space if you have a small shop. We've looked at the items that we're selling, that our public, that our customers want to buy, and they range from some very inexpensive things, but because there is an element of volume in them, they become profitable to stock and profitable to sell. These are things that the customers want to buy, and previously we would have neglected them, both in terms of promoting them and pushing them and putting them in window display space. So that we now have a more balanced view that really it's what we ought to be stocking, solely what the customers want to buy, not what the traditional jeweller wants to sell.
John has done more than just run the original software, he's also adapted it. His stock is particularly sensitive to changes in fashion. Because of the shop's position, he stocks mainly small items, so the sales needed to be monitored very closely. John has developed his own ways of analysing the data and has learned how to manipulate the software to build them into the computer's reports. He can, for example, look at sales over much shorter periods than before and spot designs that are just starting to become popular. The reports now reveal rapid changes in fashion, and that's given John an edge over his competitors. He's even discovered that he can use the reports to work out the best positions to place each item in the displays. The best-selling software for personal computers is a spreadsheet. Now, a spreadsheet is a program which takes all the tedium out of repetitive calculations and recalculations, and it's the kind of thing which really comes into its own in a small business. Now, suppose that I work for Microlife Builders Limited, and a customer wants an extension. I've got to give an estimate based on materials bought and the labour employed. Well, I'm going to need bricks, mortar of course, a couple of windows because that's what he's asked for, and the right amount of glass. Now obviously that's not every item involved in building an extension, but it's enough to explain the problems involved. Now all those materials are going to cost money, based of course on the quantities used. So multiply the number of bricks by the cost of a brick and you would get this sum here. But as well as the costs of the materials, there's the labour. There's 6 days of the brickies for the bricklaying. Then there's 3 days for the brickies labourers to mix the mortar, carry the hods and so on. 1 day here for a carpenter to put in those windows. And probably just half a day for our glazier. Now each of those people is going to cost money, which we've shown here. And all that money must be added up to give us the total cost of the job. Here it is. Now, it stands to reason this is not the amount I'm going to charge the customer. I'm in business, so I add my percentage profit. And then I present the estimate. Well, so far so good. But one of the worst things you can do to a builder, so I'm told, is change the specification. Now, suppose that my customer decides he wants a third window. Well, here we go. But the effect on the final estimate is far from straightforward. First of all, this extra window will cost more. And of course, it will need more glass. There it is. And the glass will cost more. But it will also need more time from the glazier to fit it. And that's going to cost more. There he is. Extra bit of glazier's time and extra wages. Oh, but of course, where there's now a window, there will now be no wall. And that's going to mean fewer bricks. There they go. And that'll cost less. And it'll also mean less mortar. And of course, that'll cost less. And of course, it'll need less time from the workers and so on, and that will cost less. So now, our original estimate is no good at all. Changing one number over there has affected almost every other number. So now, well, I just have to do all those calculations all over again and draw up a new estimate. But that's the sort of thing that a spreadsheet copes very well with. This is Lotus 123, set up to look like that example. Now here we've got columns for the materials, the costs, the labour and the wages. And they've been itemised for the bricks, mortar, windows and glass. Here's the total cost and here's the amount for the estimate, £1,393. Now notice that here we've only allowed for 2 windows, but just watch what happens, particularly to this final cost here, when I change the number of windows to 3. Enter 3, and they're all recalculated instantaneously, and the new cost is ready straight away. There it is, £1,489. Now that happens because there are rules which relate those numbers one to another. So, for example, the cost of the windows in this box here is the number of windows times the cost of each. And the amount of glass you need, that's what we show here, also depends obviously on the number of windows. Now, I put those rules in when I set up the spreadsheet, and you can see the rule for each box in this corner here. So box B9, that's B9, the amount of glass, is defined as box B8, it is B8, number of windows, times 2. So that's the number of windows, B8, times the amount of glass for each. Now, we've taken each window as being 2 square metres. Right, let's move over to another one. C9. C9, the total cost of the glass is B9, that's the amount of glass needed, times £12. That's the cost per square metre. And similarly, there are other rules for every box on the grid. Now, things can change. Supposing, for example, the rate for the glazier goes up from £50 a day, which I've allowed here, well, I simply change that rule. And the spreadsheet can get bigger. Supposing I want to be a bit more realistic and include the cost of plastering the walls. Well, that will need a new row, and a sensible place will be up here, just under those items for the walls, perhaps under the mortar. So I'll insert a row for the plaster. There we go. Insert row. Oh, by the way, this system uses a software add-on called HOWL, which allows me to make all kinds of changes like this very simply. Insert row, enter that, and it does so straight away. That doesn't upset the system. The software is smart enough to adjust all those box numbers automatically. Right, there's a new row there, and I'll call it plaster. Enter that, and now I need a rule for how much plaster. Well, I'll just make one up. Suppose the number of cubic metres of plaster just happens to be the number of bricks divided by 8,000. It's got to depend on the area after all. So, right, number of bricks, that's what we've got in box B6. So I enter plus B6. The plus means a formula is on the way, divided by 8,000. There we are. I put in the formula, but watch what happens here. A number goes in. It's done the calculation immediately. And similarly, I can fill in all those other blanks. Now, this is a fairly small spreadsheet, but you could work with a spreadsheet which was hundreds of boxes in each direction, and then it would be absolutely indispensable. Don't forget there are programme notes available, and the address will be given after the programme.
Next week, we shall be looking at connecting your computer to the telephone.
But until then, goodbye.
Bye-bye.